Good afternoon. Today we will discuss the topic dynamics. During the first chapter of the mechanics, that means during the discussion of statics, we know the meaning of the mechanics. Later, we go through the classification of the engineering mechanics. So, meaning of the mechanics is the branch of science which deals with the behavior of the bodies, which are subjected to force. So that means whenever force is applied on a particular body, definitely there is some change in that particular body. So that is called as the behavior of the body under the action of that particular force. That is the meaning of that particular mechanics. Now, based on the effect, that particular mechanics is broadly classified into two categories. One is the statics, second is the dynamics. What happens? Whenever force is applied on a body, then what happens? Okay, so the force may applied on a body which is at rest position, or the force may be applied on a body which is under motion. Okay, here this is the one cut. Second thing, though the body is in rest position, because of the effect of the force, the body may attain certain velocity. Whenever it is having velocity means the body position change with respect to time from one location to another location. That means under the action of the force, there is no change in its position. There is no change in its movement position. There it is called as the statics. Under the effect of force, if the position of the body changes, from one place to another place, then it is called as the dynamics. Basically, based on this particular category, based on this particular criteria, mechanics is classified into two categories. One is the statics, second one is the dynamics. Okay. So engineering can be divided into two main groups. One is the statics, dynamics. Already we discussed what is the meaning of statics means. There is no change in the position of the body under the effect of the force. Then that particular group is called as the statics. Whenever under the effect of force, if the position of the body changes means it is having certain velocity. That means the velocity of the body is considered during the discussion under the effect of the force. Then it is called as the dynamics. In the first chapter, we completed the discussion regarding the statics. Now, in the fourth chapter, we will go through the dynamics part. Okay. So already we know statics means it is the branch of engineering mechanics which do effect force on the body which are at rest. That means there is no change in the position of the body. Which are at rest means there is no change in the position of the body either before applying the force or after applying the force. Second one, dynamics. So in the dynamics, what happen? We deals the bodies which are in motion. Either before applying force, the body may be in motion, or after applying force, the body may be in motion, or in sometimes before applying force, the body in motion, or after applying the force, also the body in motion. But there is some change in its velocity. That means in the dynamics, we will consider the body may be at rest before applying force, and after applying force, the body is having some motion. Second one, the body is in motion, under motion before applying force, and whenever force applied, the body may be at rest. And the third one, before applying force also the body in motion, and after applying force also the body is in motion, but there is some change in velocity. That is the third part. That means the dynamics may be categorized as three parts. First one is the body is at rest before applying force. Second one, the body is at rest after applying force. Third one, the body may be in motion before applying force and after applying force. So dynamics later it is subdivided into two groups. Mechanics is classified into two categories, statics and dynamics. Now, once again, the dynamics is supposed to be divided or categorized into two groups. Okay, what are the two groups? First one is the kinematics. Second one is the kinetics. In both the categories, that means in the kinematics and the kinetics, in both the categories, the body which is under the action of force is having certain motion or certain velocity. But the difference is during the study, during the discussion, if the mass of the body is not considered, then that classification is called as the kinematics. Second thing, if the mass of the body is considered, both are having velocity. In kinematics, in kinetics, in both the categories, the body is having velocity. But if the mass of the body is also considered, then that particular study is called as the kinetics. Simply, we may differ the kinematics and kinetics based on the study of the mass. In both the condition, mass will present, but if mass is considered, then it is kinetics. If mass is not considered, then kinematics. Some are having confusion without mass, how it takes place. Definitely, the body is having mass. It is not possible consider a body without mass. But if we are not considering the effect or the consideration of mass, if we are not considering the effect of mass or the value of mass, that is kinematics. If we consider the mass value or if we consider the effect of the mass of the body which is in motion, then it is considered or classified as the kinetics. Okay, so here we are having clear definition. Kinematics means it is the study of motion of bodies without reference to the mass of the body. Here observe this term, reference. Without reference, not without mass. Some are having confusion. So, study of motion of body without mass. Without mass means how it is possible to exist any body without mass. Definitely the body is having mass, but we are not without referring the mass, then it is kinematics. Second thing, in that particular study, if the mass of the body is referred or if the mass of the body is observed, then it is called as the kinetics. That is the difference between kinematics and kinetics. And second thing, scalar and vector quantities. Already in the first chapter during the statics definition, we go through this particular scalars and vector. Scalar means it is an physical quantity. Scalar means it is a physical quantity which is having only magnitude. So, all the physical quantities under two categories. So, what is the criteria? Criteria based on the magnitude and direction. Physical quantities are classified in various categories. But here, by considering two important categories only, the physical quantities are categorized into scalars and vectors. First thing, whenever we consider physical quantities, the physical quantities must have some magnitude. Okay, so that particular physical quantities which are having only magnitude, that are classified as scalars. Next, in addition to magnitude, if that physical quantity is also having direction, then it is classified under vectors. Okay, so scalars are those physical quantities that have only magnitude but have no direction. Examples, mass. Mass may not have any direction. If you are keeping or if a particular object is placed on a table, that particular mass of that particular body remains the same. It may not have any direction. So, and time. So, here some people may consider time means in generally what happened, that particular minute or second dial, it is having rotation. So, as it is having rotation, that particular time may contain direction also. That is the wrong concept. Here for that particular watch mechanism only, that particular rotation of the dial takes, but we are not supposed to be concerned the time is having direction. So next, temperature. Temperature also we will observe and we will measure what is that particular magnitude. So the temperature may be measured in degree Fahrenheit, in degree Celsius, in degree Kelvins. With various units, the temperature or the magnitude of temperature may be measured, but it may not have any direction. Likewise, volumes and areas are also having only magnitudes. We will express volume in liters or in meter cubes only, but we will not express this particular volume, this much of meter cubes in this direction. We will not express like that one. We will express only in this units, either meter cubes or liters, but we will not explain, or it is not possible to explain in which direction the volume will apply or in which direction the volume will act. Likewise, we will explain the same example for area also. Area may be explained with the magnitude, that units in acres or hectares or in square meters, like that one only. But we will not express this particular area 10 meter square only, but we will not explain the 10 meter square area in this particular direction. That means these particular physical quantities, mass, time, temperature, volume, area, these are having only magnitude without direction. That's why these particular physical quantities are considered as examples for scalars. Next one is the vectors. So the physical quantities which are having direction in addition to the magnitude. Already we discussed physical quantity means it must have some magnitude. In addition to that magnitude, if the physical quantities are having direction, then that particular physical quantities are classified or categorized as the vectors. So we will consider some examples for these vectors. So displacement. So whenever a body is supposed to move from one location to another location, from one point to another point, along a shortest distance or along a straight line, then only we will consider that as a displacement, which is example for vector. Later, velocity. So I think already you know the definition of velocity. The change of position of the body with respect to time, that means displacement per unit time is defined as the velocity. So velocity, force, acceleration, these are the examples. These physical quantities are example for vectors. So already we discussed regarding the scalars and vectors and statics and dynamics during the first chapter itself. Once again, just it will be revision for this particular topic or for this particular chapter, dynamics. Okay, so a small quiz. Already we go through this particular topics. So what are the example for a scalar or a vector? Means length is the example scalar, and volume is example for scalar, and displacement is example for vector, and velocity is also example for vector. Acceleration is also one example for vector. So in this particular class, we discussed regarding the statics meaning and the dynamics meaning. So automatically we will know the difference between statics and dynamics. Later, the categorization or classification of dynamics also. So dynamics further it is classified into kinematics and kinetics. So later we go through the scalar and vector. So in this class, we completed this particular meaning or concept of this particular topics. So we will start the next topic after certain time.